So for today's topic, we're going to talk about absolute dating. Describe the different methods to determine the age of stratified rocks. What is absolute dating? It is the process of determining an age on a specified chronology in archaeology and geology. It also allows scientists to assign numbers to the breaks in the geologic timescale and get an absolute age of a rock or fossil. Some scientists prefer the terms chronometric or calendar dating, as use of the word absolute implies an unwarranted certainty of accuracy. This figure shows what is the differences between relative dating and absolute dating. In relative dating, we will know which is the youngest and which is the oldest. But in absolute dating, we will know the exact age, or what we call the absolute age. There are three methods in absolute dating: the radiocarbon dating, the potassium-argon dating, and the uranium-lead dating. Radiocarbon dating. It is used to find age of once living materials between 100 to 50,000 years old. It is also referred as carbon dating or carbon-14 dating. It is usually used to determine ages of human fossils and habitation sites. Potassium-argon dating. Potassium is common in many minerals such as amphibole and mica. With its half-life, the technique is used to date rocks from 100,000 years over a billion years. This figure shows how potassium-40 becomes our argon-40. Remember, argon is a gas, allowing it to escape from molten magma, thus, any argon that is found in any igneous crystal probably formed as a result of the decay of potassium-40. Now, measuring the ratio of potassium-40 to argon-40 yields us to estimate of the age of that crystal. Uranium-lead dating. It is one of the oldest and most refined of the radiometric dating schemes. It can also be used to date rocks that form and crystallize from about 1 million years to over 4.5 billion years. Uranium-238 decays to lead-206 with a half-life of 4.47 billion years. Uranium-235 decays to lead-207 with a half-life of 704 million years. Remember, uranium-lead dating is usually performed on zircon crystals like this. When zircon forms in an igneous rock, the rock crystal readily accepts atoms of uranium but rejects atoms of lead. Now, if any lead is found in a zircon crystal, it can be assumed that it was produced from a decay of uranium. Zircon crystal. This figure is about 4.4 billion years old, and this is believed to be the oldest piece of earth ever found. To determine the age of a zircon fragment, scientists first used a widely accepted dating technique based on determining the radioactive decay of uranium to lead in the mineral sample, but because this technique might give a false date due to possible movement of lead atoms within the crystal, the researcher turned to a second sophisticated method to verify the finding. And they used the technique known as atom probetomography. Because of this, it is possible to identify an individual atoms of lead in the crystal and determine their mass. And it was confirmed that the zircon was indeed 4.4 billion years old. Thank you for listening.